Products to sums. How do we convert a product of two trigs into a sum of two trigs? And basically it's using our compound angles but in reverse. So you sort of have to think where it comes from. So if I've got 2 cos, it must have come from the expansion of cosine, because the expansion of cosine, we remember, is cos, sine. But the sines have disappeared. Well, that's all right, because one of the expansions would have gone minus sine. The other expansion would have gone plus sine. So if we add the 2 coses together, then we know we'll end up with 2 of the coses. So always think about where it's come from, and that's makes it a bit easier to recall the formula. So that's if we have a cos. If we have a sine cos, then it must have come from the sine. And again, if you think about it, one would go sine cos sine, but again, you'd have one would be a positive cos sine, the other would be a negative cos sine, so the cos sine cancels. So it's the sines added together. Now on that one, be very careful, because A minus B, A plus B. So the A's got to be first. It's got to be with the sine, because you remember sine, cos, sine. So be careful with that one. And then the other one is the sine, which again must have come from the cosine one, because cos, sine. But this time it's the coses that are cancelling. So instead of adding the 2 together, we must subtract. And again, in this case, we need to be careful, which one comes first. So the way I've written mine is that I've always gone A minus B first, so it's nice and consistent. So let's express as it'll either end up being a sum or a difference of a couple of trig functions. So if I have cos sine, oh, hang on a sec, cos sine, I didn't have a formula for cos sine, I had a formula for sine cos. Phew. Fortunately, multiplication we can do in any order, so I can turn that into sine cos. So sine cos must have come from the sine formula. The way I've written mine is they all start with the minus. The order is important, so I'll go x minus 5x, and then in the other one x plus 5x. Sine a negative 4x, I suppose we could leave it like that, but sine's an odd function, so I could rewrite that as minus sine 4x plus sine 6x. Cos, cos must have come from the cos one, so I get a half of 2, because our formula is 2 cos, not just cos. So we're actually going to have a half of this. And you'll notice here I've done the plus first and the minus second, because if it's addition, it actually really doesn't matter, does it? Because you can add in any order. Reality is I probably would have normally gone 3 theta minus 5 theta first, because I keep the minuses first, but I just put that one there to point out, hey, actually, it doesn't really matter when you're adding. And we end up with, oh, hang on a sec, cos minus 2 theta. Cosine, even function. So that's the same as cos 2 theta. So if we want to work out 2 sine 45 cos 15 then. Well, sine 45 is okay, we've got an exact value for that one. Cos 15. Well, I suppose we could create one for cos 15 and then work it out from there. Or we could use this idea of product to sums. So sine cos must have come from the sine one. So it'll be sine 45 minus 15, which is 30, one of our exact values, plus sine 45 plus 15, 60, one of our exact values. So we get a half plus root 3 on 2, 1 plus root 3 on 2, which is probably quicker than, as I say, trying to work out what cos 15 is and then multiplying out and doing all that. Prove that sine squared 5 theta minus sine squared 3 theta is sine 8 theta sine 2 theta. Sine 8 theta sine 2 theta. So I'm going to start with the right hand side, seeing we're talking about going from products to sums, it makes sense. Again, I've got half of it, because remember our formula is 2 sine. So I'm going to end up with half. It must have come from the cosine, because we've ended up with sine. I'll start with the minus. So we go 8 theta minus 2 theta minus the cos of 8 theta plus 2 theta. So we get a half of cos 6 theta minus cos 10 theta. We're trying to show it's sine squared 5 theta minus sine squared 3 theta. How on earth can we do that? Now we use our double angle results. So cos 6 theta is twice 3 theta. So I know it's going to be 1 minus 2 sine squared 3 theta, and 10 theta is twice 5 theta. So I can write that one as 1 minus 2 sine squared, but of course it's negative all that. So we end up with negative 1 plus 2 sine squared. Tidying all that up, we get the result that we're looking for. Okay, that was products to sums, which is in the syllabus. Now we're going to look at sums to products. Technically not in the syllabus. I say technically because surely if we've got a formula from going products to sums, which is in the syllabus, all I got to do is read it backwards, and then I got to sums to products. But these are much more fun. Oh, you're going to love this. So if I want to add two sine functions together, look at this wonderful thing that we get. 2 sine half of a plus b cos half of a minus b. No, we don't remember it like that. 2 sine half sum cos half diff. 2 sine half sum cos half diff. Difference. Alright. If we're adding the two coses together, then look what we get. 2 cos half sum cos half diff. So notice they both end in cos half diff. They start with whichever one we're looking at. So sine or cosine has 2 times in each of these. Well, what if it's cos minus cos? Cos minus cos. We end up with this lovely thing. Minus 2 sine half diff. You're about to take a little exploration inside my head, and this could be dangerous. Watch out. So the first two, nice and easy, because we end with cos half diff. And it starts with what it was. But hang on, I've thrown this minus one in. That's a bit different. Oh, that's the key. That's a bit different. Well, therefore, my answer is going to be a bit different. So instead of 2, I got minus 2. That's a bit different. Right? Instead of it being the same as what we want, it's sine instead of cos. So that's a bit different. And instead of ending with cos half diff, I am with sine half diff. That's a bit different. That's how I remember that one. Because it's a bit different. So the other two are straightforward, and then this one, that's a bit different. Ah, great question. You'll notice I haven't got a formula for sine A minus sine B. Some books will have one, but the reason I don't worry about it is because sine is an odd function. So I can always write the difference of the sine as the sum of the sines. Let's prove this one. Cos 75 plus cos 15, sine 75 minus, so I'm glad you asked, because look at the denominator here, sine 75 minus sine 15. And so that's what I'm saying. I will change that denominator. I will make it a sum. And then I can go with our formulas. So cos plus cos, twice cos, half sum, cos half diff, over 2 sine half sum, cos half diff. We end up with the cosine of 30 over the sine of 30. Because notice the cos half 90s are going to cancel. And the 2's cancel as well, by the way. So that would be the cotan of 30, which is the square root of 3. We want to solve this equation. Sine x plus sine 3x is equal to 0. So sine plus sine. 2 sine half sum cos half diff. So I get 2 sine 2x cos negative x is equal to 0. Now that's a quite simple equation to solve. I'll just change that cos negative x to a cos x. So either sine 2x is 0 or cos x is 0. Alright, so when's sine 0? Well, it's 0 at 0, 180, 360. But we're going around twice because it's 2x. So 540, 720. Divide everything by 2. So I've got those possibilities. When is cos equal to 0? At 90, 270. And that's it. So combine those all together. Well, we already had 90 and 270. So actually, there's all our answers. 0, 90, 180, 270, 360. And you'll never guess which exercise we're going to do. Oh, okay, so you will. Right.